Sentiment Analysis for Super Applications in Indonesia, a case study of Gov2Go app. Recently, the government of the Republic of Indonesia assessed that the number of applications spread across various ministries and regional institutions were less effective and efficient. Therefore, the government will prepare a super application to replace thousands of applications to support electronic government and will use 2,700 data centers that can produce data integration according to the One Data Policy concept. To support this initiative, we proposed a recommendation system framework with a sentiment analysis, based on expectation confirmation theory (ECT), that can be used as a reference and consideration for the Indonesian government in building and releasing this super application. Positive or negative sentiments between expectations and performance mediate the disconfirmation effect. Positive disconfirmation will be achieved if a product exceeds expectations, and conversely, negative affirmation if the user tends to be unsatisfied. Many studies have examined the process of utilizing a new system oriented toward the multi-platform superapp ecosystem with a focus on covering survey, application design, development, and production, the impact of which was then measured by several indicators for the Electronic-Based Government System (SPBE). However, in this study, we focused on sentiment analysis methods to support the generation of new recommendations by leveraging data on past user interactions through recording relationships between users and items products. The advantage is that sentiment analysis can find the polarity value of sentiment conveyed by the user. This study proposed a new scheme to measure user satisfaction by adding artificial intelligence constructs to ECT with the object of research in the form of 1,600 comments reviews on the Gov2Go app. The research environment is cloud-based at www.kaggle.com with a Python script to develop a machine learning classification model. Pre-processing steps include 1. Label ratings for easy analysis, 1 worst, 2 poor, 3 average, 4 good, 5 excellent. 2. Data cleaning with NLTK stop words, tweak preprocessor library, and converting words to their primary form with NLTK word net lematizer. 3. The total data to be mined will be 1,592 rows. It is also specified that 65 is the maximum length of words to be converted to numeric with the Keras tokenizer library. This clustering is intended to group users based on the content of their comments. The algorithm is k-means because it is simple, fast, and the most popular. We used the elbow method, the best approach to finding the number of clusters in k-means. The results indicate that 5 is the optimal value of k, then we used the principal component analysis algorithm to simplify the data. Sentiment analysis aims to predict the polarity value contained in a comment based on the weight of subjectivity. This value can be positive, neutral, or negative. Here, we used the text blob algorithm. Each polarity value equal to 0, 0 is marked as neutral, values above 0 are marked positive, while those below 0 are marked as negative sentiment. Label normalization was carried out to ensure the number of target labels was balanced. So, ratings of 3 to 5 are combined into a satisfied category, while those for ratings 1 and 2 are made into an unsatisfied class. First, the classification of satisfaction with deep learning is the LSTM model. The first layer used is embedding, the next layer is a bidirectional LSTM with 128 perceptrons, then 128 perceptrons in the next layer with a 50% dropout technique, then, we use 64 perceptrons in the third layer with a 50% dropout technique in the next layer, next, 32 perceptrons in the fourth layer with a 50% dropout technique. The output of this network is a binary class with a sigmoid activation function, model checkpoint, early stopping, and callback methods are also used to make the training process more effective and monitored. The second is sentiment classification using the naive Bayes algorithm. The TF-IDF method from sklearn is used to extract existing features in the training data. The pipeline is intended so that the resulting model can be directly applied to new comments without a separate tokenization process. In the first experiment, we used LSTM with 60 epochs initiation. A total of 30 epochs have been achieved, with a validation accuracy value of 97.49%. In the second experiment, the accuracy of the naive Bayes algorithm produces 94.22%. We have developed a sentiment analysis framework used for ECT so that it has the potential to assist the development of a super application for the government of the Republic of Indonesia. The data comes from comments in the Google Play Store. The proposed scheme includes input text data cleaning, tokenization, clustering, TF-IDF feature extraction, and classification with naive Bayes and LSTM models. The LSTM model achieved an accuracy value of 97.49%, which is 3% better than the naive Bayes method. Both models are used to process incoming comments, and ratings automatically classify users who are satisfied or unsatisfied in the value of sentiment polarity, positive, neutral, or negative. This framework is expected to be used to improve the features of the following application version based on users' comments and ratings on social media such as the Google Play Store. Thank you.